Since I think the fraction object is a very practical application of operator overloading, so it's not as contrived as some of the other examples we've seen, I think it's a good platform to talk about a few of the other ways we tend to see overloaded operators getting written. And this piece of code I'm going to go through is actually already done. There's no exercises to do here. I just want to talk about it. I just want to pontificate. We have already seen that we can define our own operators for types, but the operators that we normally define, or the ones we've been defining so far, have just been, they've sort of been just like regular functions that live in the global scope, just like main or any other function we could write. It's just that it's an operator and not a function. The issue is functions out here don't have private member access. And there are lots of reasons why that can be a bit of trouble, because if we're working with arithmetic on fractions, it might be sort of nice to have access to private data inside the fraction object. And if I'm the one writing the fraction class and I'm the one writing the operators, maybe I want to give the operators private member access. There are a few ways of doing that, but one big one that we really ought to learn about is you are allowed to put operator definitions inside a class definition. So we'll scroll up and then we'll just take a tour. The first thing I want to point out is, in this variant, I have used the standard libraries function for computing the greatest common divisor. Because it provides such a function, I really should use it. In the previous video, I wrote it myself because I wanted to prove that you can write it yourself. All is not lost if you don't know how to do something. Just because a mathematical concept is needed doesn't mean you couldn't figure out a way of doing it. And I often find that I've met quite a few programmers that are like this. There are programmers that even though I feel that there are some tasks people can sort of synthesize, maybe not that they can't create a perfect solution for off of the top of their heads, I meet a lot of programmers that get so invested in the standard library that they're unable to perform simple tasks because they just expect that if the library can't do it, then it's impossible. So it's useful sometimes to be able to break away from the standard library. But yes, it's true in actual code, it's good to use the standard library if it provides the feature that you want. Here I have some operators that I've defined inside my class. These are actually part of the fraction class now. The key difference when you define an operator inside your class, and you might compare this plus operator to the one in the previous videos, when you define an operator inside the fraction class, one of the operands to the operator is automatically going to be the current object. Just like how if I call the getNumerator function on a particular fraction, the getNumerator function works on this particular fraction object, the current object. When you define an operator inside the fraction class, one of the operands to the operator is the current fraction object. The other operand is one that came in from outside. So if I were to write something like a plus b, in C++, when you define a binary operator, so one that takes two operands, when you define a binary operator inside the class, the left operand is always assumed to be the current object. So in this case, in the plus operator, the left operand will be the current fraction object, and this other parameter that I've called other will be the right-hand side of the addition operation. So to add two fractions, well, I compute the numerator of this fraction multiplied by the denominator of the other fraction, plus the denominator of this fraction times the numerator of the other fraction, all over the denominator of this one times the denominator of the other one. One other thing you will notice here, I was given a fraction object called other, and the member denominator is private, but I'm inside the fraction class, which means any fraction object that I encounter, whether it be the current object or some other fraction object, I have private member access. Anything inside the class gets private member access to every instance of that class. So I'm allowed to just go in and look at the numerator and denominator of any fraction that I encounter when I'm inside the fraction class, which this operator is. Okay, so that means that the plus operator now takes only one explicit argument, and that's the right-hand side of the plus. The left-hand side of the plus is always assumed to be the current object. So you can see I'm just using the members numerator and denominator. And then here is the minus multiplication and division operators written in the same way. And there's my less than operator. See the previous video or the code for the previous video for an explanation of how that works. One other thing to notice is here I have written the negation operator. So this is if I write something like negative f, and f is a fraction. Notice this is not subtraction. I'm only operating on one fraction here. Subtraction would be doing something like f minus g or something. This is just operating on one fraction. And so if I wanted to write an operator like this out in the global scope, I'll just take a detour, I might write something like this. So I want to negate a fraction object. So it's operator minus. In this operator, I'm only taking one fraction object. So fraction const reference f. And I guess I would return something. I guess what I'm returning is a fraction, so it returns a fraction. It takes one fraction object. This is the unary minus operator, negation. It takes one fraction object f, and what does it return? Well, I guess what it returns is fraction result would be negative f dot get numerator, and then f dot get denominator. So it just negates the fraction that it was given and returns that result. This is a unary operator, an operator that takes one operand. There's also a minus operator that takes two operands. That's this one. Oops, that's the one in the previous video. That's the one that is in this file up here. And so there are two different minus operators, the same way that there are two different operators that are called star. There's multiplication and the one that you use on pointers that I know you don't want to think about. Of course, how I differentiate them is based on how I define them. If I want to define the unary minus operator inside my fraction class, remember that one operand, if you define your operator inside the class, one of the operands of the operator is automatically going to be the current object. And in this case, the unary minus operator doesn't take two operands. It only takes one. So if it only takes one operand, it doesn't actually take anything as a parameter because the single operand of the operator is automatically assumed to be the current object, the current instance of the fraction object. And so I've defined a unary operator here. We'll need a few unary operators during this course. And although I know this is a bit of a sort of a harsh introduction to the subject, it is something we have to do occasionally, and this notation is a little bit clunky no matter how it gets introduced. So the point of the video is that I am now allowed to define operators either outside the class in the global scope, like this, or I can define them inside the class. If I define the operator inside the class, and it's a binary operator, so it takes two operands, the left-hand side, the left hand of the operand, is automatically interpreted to be the current object. That means that the operator only takes one explicit parameter, and that's the right-hand side. In the event that it's a unary operator, like the negation operator, then the only operand is the current object, and therefore it takes no explicit parameters. So the issue with that is, when I want to define an operator, for example, I want to define what happens if I push a fraction into my output stream. I actually can't put this operator in the fraction class. Because remember, if I put an operator in the fraction class, the left-hand operand has to be the current object, which has to be a fraction. But this operator doesn't take a fraction as its left-hand operand. So I have to put the operator outside. And that means it could be a bit of a mess if I do need private member access. Now, it's worth noting, as this comment does, I could put this operator inside a class, but it has to be the class of the left-hand side, the OStream class. And I'm not the writer of the OStream class, so I'm not allowed to go jamming in operators that weren't already there. So in this case, the only choice I have is to put the operator outside the class. So you have lots of places to put operators. If they need private member access, you want to put them inside the class. There's another option we'll see later this week that's not really a good idea in general, if you can avoid it. But there are cases like this where you're not allowed to put the operator inside the class, and then you have to come up with some alternative. I guess before I finish, I better run the program at least once. Okay, so it's giving me some error here because it's complaining that I define my own unary negation. So as you recall, in the middle of the video, I went and defined my own second unary negation operator, and then I forgot to save the file. So we'll just compile that again. Sorry about that. Sorry for the mess there. Compiled it again. As you can see, it compiles just fine. So I guess I don't have to edit the video. We try running it, and we get this. So we can see here, I'm able to compute negative x by just negating my fraction using my unary negation operator. I've got x plus y, y plus z, x times y as before, but unlike before, all of those arithmetic operators are now physically inside the fraction class and not in the global scope.